Okay, so I was talking about scoop import command. Okay, so we can do the different scoop import command. Okay, so depending on the use case and parameters, right, we can pass it and we can use it, this is scoop import command. So for if you have 100 table but you don't want to import the particular department table, so you can keep it in the list of exclude table list. So as many as number of tables you can give exclude, so it will skip while importing the data, it will skip. Okay, so this is the scoop related. And next component is the Flume. Okay, so Flume is very simple to download, okay, and install. So you go to the Flume download website. Okay, so here we have to download this Apache Flume. We have to download this Apache Flume 1.110. This website we have to, this particular tar file we have to download, and then we set the bin path. Okay, so I will go to my bash rc, so nano bashrc. So most of the Hadoop ecosystem component are just you are setting the home path and bin path, and then you can use it. Okay, so you download the Flume and keep it in your software folder, and then you set the Flume home path and bin path, and after that you can use Flume ng command. The Flume ng command is a command like you can give the more parameters, but it is for testing, right? The Flume ng is working. So in the Flume, basically, we have to create a configuration file. So when I go to Flume folder, so there is a con folder. So suppose I want to do Twitter, right? I want to read the Twitter data. Just I'm giving us some idea, right? How we do write a configuration file. So we have to write one single configuration file, and this configuration file I will use in my Flume ng command. So what I will do, I will create an agent. An agent is a wrapper of source, channel, and sink. So some source I'm telling here, Twitter is my source. Channel I'm telling memory channel, and sink I'm telling Hadoop distributed file system sink. And here I'm telling further more detail about my source. So how I will write the configuration? Okay. So how I will write the configuration, basically, I will be defining the Twitter agent dot sources dot Twitter type. So here is a Twitter API is there. Okay. And here is a secret key, access key, consumer secret, and consumer access secret key. So these are the 4 keys we have to take it from our Twitter account. So we should have a Twitter account, developer account. From there, we can copy these 4 properties and paste it here. And then next thing is we are setting is here the Twitter keyword. So like there are so many tweets are there on the different topics. Suppose I want to get some latest topics, and I want to specify those words, keywords, and I want to get the tag tweets. I want to get it. So I will get the tweets for those particular words. The sink, I can set the sink. So sink type. So sink type is Hadoop distributed file system is a sink type. And what is my Hadoop file system folder? Where you want to get all your Twitter data as files. Are you getting any? So basically here we are creating my sink type, sink path, file type. So these are the some set of properties. These are the some set of properties I will be specifying in my configuration file. And then I will run the Flume ng command with this agent, Twitter agent, which I given a agent name is a Twitter agent. I will use the Flume ng command. So Flume ng command we will use.
Yeah, sorry to interrupt. What is the purpose of Flume? Is it extracting data from Twitter and putting
not only Twitter? Twitter is a one kind of source. What that is a one example. Okay, but it could be any source. Like you can say like some REST API you are reading the data, or Kafka you are reading the data, or you are reading the data from any file system like Hadoop file system, one file system, local file system to Hadoop file system. So there is a spool dir is there. So there are the different use cases. So Flume is for especially semi-structured and unstructured data transfer, okay, from any source which is a streaming data source, okay, like Twitter is a streaming source, or file system you can do. So whatever you are doing, Hadoop put command, fs file system, you can write the file into the local file system to Hadoop. You can use spool dir. So spool dir is a one type of right? This is a spool dir configuration, So there you are telling what is my source location. The source location is your local file system location, where is your files are there. And once your file is completed, you want to mark dot completed. Okay. So when I will show practically, and there is a flume ng command is there. So you will use this flume ng command. When you run this flume ng command, it will start transferring the data from your like source to target. So ultimate purpose of the flume is like one source and one target, and you have defined in the configuration file, and particular source, it will start reading data and write to the target. That is the end goal. Okay. And this flume ng command will start transferring the data. So scoop, we know it's for the SQL structured data, but flume is for the structured, unstructured and semi-structured. Even for SQL databases also we can use flume. So in the flume documentation you go, here you can see lot many, if flume user guide you go, documentation. So you will see so many different sources and targets are there. If you see here, these are the different source type and sink type. Okay. Yeah, here, flume sources. So Avro is a one source, Thrift is a one source, JMS like Java application, Java messaging service, spool directory is a one source, Twitter is a one source, Netcat, right? You are transferring the data within a network, like in the Unix environment. Netcat is there. Sequence generator, right? You want to generate a sequence number, right? Kafka, you want to get the data. So these are the different sources. HTTP source, like HTTP URL is there. You want to get the data from there. And target is a flume sink. So SDFS sink is a mostly we use because we want to get the data into the Hadoop file system. But directly you can get the data into Hive table also. Okay, like Scoop can not only bring the data in SDFS file system, it can directly load the data into Hive table as well. Okay, so you can do that also. Avro sync is also there. So this is the combinations, right? You can use any combination of source and target sync. Okay. So you can define memory channel, file channel, JDBC channel. So JDBC channel is used for the SQL databases, right? Suppose you want to get the data, so you have to use JDBC channel. Okay. So generally flume is not meant for structured data, because structured data we have already very like a tool which has a very good capabilities, right? Scoop. So we go for that. But flume is also providing the JDBC channel, right? One channel is there. So you can use JDBC channel. Kafka channel is there, right? You can write the data to the Kafka channel, or otherwise you can use Kafka sync. Okay.
So
purpose
of Scoop and flume is same. Source to target,
Scoop and flume purpose is same, like ingestion of the data in Hadoop file system, but for different types of data. Scoop is doing for structured data, but flume can do for any type of data, even structured data also it can do. But main purpose of flume is unstructured and semi-structured data. The data which is like you can use like files data or streaming data. The data is coming from Twitter or some REST APIs, right? So that thing you cannot do with Scoop. Scoop is only meant for SQL, okay? But flume can be used for any purpose, okay? So flume is, we have to write configuration file. For every type of transfer of the data, we have to write this configuration file. And once we write the configuration file, we have to use this flume ng command. And flume ng command, we tell the path of the file and tell the agent name. So this agent name I'm specifying here, right? And once I start this, it will start reading the data from the Twitter. Like I want to generate the sequence number. Okay, so 1, 2, 3, 4, 5, like sequence number I want to generate. I can use this particular type of source. So source type is a sequence. So these are already predefined source and target. Okay, so you have to just use them and do your data transfer. It is not doing any manipulation. You are doing data transfer. But if you want to do some manipulation, also some event handling you can do. You can write your custom flume processor. Okay, that is possible also. Even Scoop also, you can customize your Java class. If you can write your own custom Java class and you can Scoop import, you can do. So that is.
Can we do some transformations? Can we do some transformations before loading
Java
the data?
code you are writing, you can do anything, right? You can write anything, right? Java code means like you can do full customization, you can do, right? Whatever you want to do. Okay, but you will not get any library for the transformation, right? Like Spark is for the fully for processing, right? So Spark you can use for the transformation, so they are providing the library. But here in Scoop and Flume, if you want to do transformation, manual custom code you have to write for transformation. Suppose I want to do filter. Okay, so what I will do, right? In the Java, we can use Java 8 Lambda, and then we can do the filter, right? So we can write like custom code we have to write Java code for filter, right? So filter, map, all these things we can implement, but we have to write our own custom code. Okay, but in the Spark, you are getting the library APIs, direct functions are there. So there Spark is basically manipulating everything on your behalf, right? But here in the Flume, you are writing your own custom, right? You have to write event handling. You have to write some event handling code you have to write. Okay, so that code you should have the proper Java knowledge, right? Even you are writing in Hive UDF, so you should have knowledge of Java. So Java knowledge is required in Hadoop, where you have more customization things than you need. Otherwise, Hadoop component, and if I say programming is not required, so Hadoop is not having any programming. Okay, except the Hive is having SQL. But if you want to go more customization, right? Hive UDF, Flume processor you want to write, so then you have to write Java code, and MapReduce is the Java code. So some places the Java code will come, you have to write, but that is more customization level you want to go. Okay. Okay, and HBase. Okay, the next component is a HBase. Just I cover HBase also. So HBase is a NoSQL database. Okay, so how to install the HBase? I will share all these documents so you can do the installation and this one. And I will give the proper one document which you can follow and do the all installation. So when you want to do installation of HBase, so first you have to find the location from where you want to download the HBase. Okay, so there is this wget command, or you can see this HTTP location. Okay, so this HTTP location you go here, you can find the HBase 2.5.4 bintard gz. So again, the same thing we have to do. We have to download this HBase, and then we have to set the export HBase home and HBase bin path. Okay, and one more thing, we have to set the Java home path. We have to set in HBase env.sh. So if I show you in my HBase configuration folder, okay, when I go to the HBase installation folder, here software and HBase. Okay, HBase is not here. Actually, it is in the CD USR local CD HBase. So actually HBase is installed here. So HBase we didn't keep it in the software. Okay, HBase is here. If you see LL, so you will see here the all configuration is here, the HBase. So I have mentioned here where you have to keep it HBase. Okay, so you have to create one HBase configure user local HBase conf, and this file you have to put this configuration. So here you are, because HBase uses the zookeeper. Okay, because HBase is for the high availability is use the zookeeper. Okay, so zookeeper is like a coordination service which is providing the high availability. Okay, so HBase is having architecture like HBase has the master server and region server. Okay, if you go through the HBase architecture, I will tell more in detail HBase architecture. So HBase architecture is we have master server and region servers, and then we can have like master server. So client is interacting with the master, and zookeeper is like a coordination service. And region servers have regions. Okay, and HBase is also storing the data in Hadoop file system only. So there is a file named H file. H file is a storage file in HDFS for HBase. Okay, so HBase is using the H file to store the data. So when the client is requesting to read and write the data from the HBase table, so first is reading the data in the memory location in region server, and then once the region server memory is full, then it will go to the H-base H file in HDFS file system. Okay, so this H-base architecture, so these are the major component are there: H master, region server, and zookeeper. So zookeeper is providing the high availability. If any region server is down, so zookeeper will allocate another region server to the master. So master can find another region server with the help of zookeeper. So this is the H-base architecture. Okay, so how to install the H-base? So we have to set this configuration. So this the Hadoop location. This is my Hadoop location. There I'm creating a H-base file, H-base location, and the zookeeper. So once I set it this, so I have to go to the root folder, and then I will go to the my bin, and then I will start the H-base service. And once I start the H-base service, then I can start my. Okay, so first I will be here, and I will be. Okay, I will go to the bin directory, and here I will start the /start hbase.hs. So I will start my HBase service. Now it's done. Now exit, come out. Okay, and now you start HBase shell. So this command will start you is HBase prompt. Same like a hide prompt is there. We'll get a HBase prompt. And then we will do the command here. Suppose I do list command. So I'm getting my tables here. Suppose you want to read data of any table. So scan command is there. Just single code you give emp table. So you will getting a data. Suppose another table we check it emp1. See, this one has the data. So emp2 table has the data. So here this is a column family. You can see here one is a personal data column family. This is having the two columns, city and name. And one city column has this value, and then name value this one. And this is the row. So for the same row, like two column family, one column family has two columns, right? So if I want to get particular column family data, so I can read it, okay, or particular row ID data. So I did this, and then I gave. So I will get it here, the data for a particular row ID. So I'm using a get command. We can use a lot of commands are there. So those commands are basically giving you like all H-base shell command, like put command. So you can create a table. Okay, like this is a table. So I want to create a table, new table. So create table and with the column family. So now I'm going to create a two column family, personal data and professional data. And now I do the list. I will see the emp3 is created. Now I want to write the data. So this put command, I will change the table name here. And I'm giving the row ID. Row ID is a unique row ID value, which is identifying the specific row. Okay. So I will create, I will use a put command. So put command is used to insert data as well as update data. Like if the row ID is already present and column family is already present, it will insert into the existing one. If it is not present, it will create with the put command. The put command is used for writing and updating. Okay, so you are creating a data. So we can do programmatic way also, like we can use some Java APIs code we can write, and that way we can write a bulk data. I mean, right now I'm writing the data row by row, right? So scan command I will do, I will get all data which I have written in the table. I can use a scan command and get command. Scan command is basically scanning the whole table. Okay.
So what is the main purpose of the HBase?
HBase is a NoSQL database. Basically, it's a NoSQL database. It's like a Cassandra Mongo, similar to Cassandra Mongo. It's a NoSQL database. Like it's a horizontal scalable database, right? Where you can store the data in the large amount of data in the horizontal scalar manner. Okay. So we can use the HBase commands. So there are many more commands are there. HBase is having like a Like you can create data, update data, read data, delete data. You want to check whether the table exists or not exists. So you can use exist command. So exist command will check. If I say exist, I say emp3. So it will tell me my table is present or not. So these are the basic command, right? Table does not exist. Okay. So when I'm just doing like a command, like here is giving true. So table exists. Okay. So table exists command, and there is an enable disable command. Like you want to make it disable, like anyone cannot drop the table. So you use disable. Okay, now you drop table. If you enable, okay, now we drop table. Okay, only drop is there, sorry. No need of table. So now it is saying the table is enabled, disable it first. So when you disable it, when you disable command to use disable, then it will be disable the table. Now you drop table. So now it will allow the drop. So now table is not there. Okay, so when you do list, like emp3 is not there. So this is just command practice, right? You can do command, and you can use a programmatic way to write data into the HBase table. Okay, so still some more component is there, right? Okay, Cassandra, Mongo, okay, and there is Elasticsearch. So these are the Spark is there. So Spark installation is very easy. Like you go to Spark download, you just search here Spark download, and go to the Spark website, and here you find it latest version, whichever version you want, 3.3.2, and this Scala 2.3 version. So Spark is written in Scala. So you can choose this version and download this star file. Once you download the star file and set the home path and bin path, and then you can test it your Spark. You can write Spark -shell. So once your path is set, you can get the Spark Scala shell. So PySpark or Spark Scala shell. So you can, if you type PySpark, to type PySpark, your PySpark shell will come. PySpark shell is a triple greater than sign. So triple greater than sign, you can get the PySpark shell. So you can write the command here. Okay, but this is not a command. This is a command line way, interactive shell. But if you want to write a program, so you have to use some IntelliJ IDEA. So IntelliJ IDEA, you have to download it, and then you can write your source code in the IntelliJ IDEA. So IntelliJ IDEA. So IntelliJ IDEA is for Spark Scala, and if you want to go for PySpark code, then you have to do PyCharm. So PyCharm is for this one. PyCharm, you have to download this PyCharm. So PyCharm is for PySpark code. So you can write code, and then you can do the Spark submit command to run your job in the cluster. Okay. So once you run the command, then you can see your job, how it's running. And Spark has more integration. Spark can read the data from MySQL. Spark can read the data from Hive. Spark can read the data from Cassandra, Mongo, HBase, Flume, anywhere. Like you can read data from anywhere, right? Spark has a lot of integrations. Okay, so Spark part is like more like a integration, right? So Spark is a processing engine. Spark is not storing any data at all, right? It is just the processing. But Spark has ingestion, like it is reading the data similar to the Scoop it can do. So Scoop is only ingestion. Scoop is not doing any manipulation, transformation. But Spark is giving the full flexibility of ingestion plus analytics, right? So why you will go for the Flume for the customization? So Flume and Scoop you just for ingestion. After that, you will be using Spark. Or Spark can do also reading data from your files and database, and then you can do transformation and you can write the data to the target. So Spark and these all you can use ETL. extract, transform, and load. So you can read the data from the different sources and transform, and then finally load the data to the target. So when it comes to writing a pipeline, so you will be using the Spark. So Spark is a distributed framework, and which is in-memory computation. You are processing the data in memory. It is more faster, like 100 times faster in memory and 10 times faster in the disk, and it is giving more computation, faster computation, right? So, but the main constraint is the Spark is like you need a very high configuration RAM, then only you can process the data you're faster. So if you are using very high configuration RAM and this memory is not a big problem, we can have a memory good configuration and then we can use Spark. Okay. So why it is overcome to the MapReduce? The one thing is Spark is using library, and it is directly you can use library, and Spark is giving a support of the multiple languages like PySpark, Scala, Java, Spark with R, Spark with SQL. So you have a different flavors are there. And Spark is giving a set of modules, like Spark Core is a base module, and on top of that you have Spark SQL, and Spark streaming, Spark machine learning, Spark graph, Spark other integrations, like different integrations. So Spark is giving one set of modules in a one unified framework. But Hadoop is having separate component. If you want to go for ingestion, you will go to the Flume scoop. If you want to go for analytics in Hadoop, you will go for Hive on MapReduce. Okay, or if you go Pig also, you can go. Or if you have to do some scheduling, you have to go with the Uji. So there are the set of tools are there. You have to use those set of tools, separate tools. But here in Spark, everything you are getting in a one single place, right? Okay. Okay, so meanwhile you install this one, and I will cover some other installation, and tomorrow I will cover the DevOps one, Git, Jenkins, and some Docker Kubernetes concepts. So what is the role of containerization in the big data? So nowadays, this manual installation taking too much time, right? Like we are completely installing everything from the scratch. But why it is essential? Because containers, there are some limitations, right? Because containers went down, right? Or like your machine is crashed, right? So everything is gone, right? In the one single machine. So in that case, either you should have a set of like a Kubernetes and Docker set of cluster you should have, not a single machine. So there you can overcome. Or if you are using the what is the advantage of you are getting the Docker Kubernetes containerization, like you are just creating an installation once and you store as an image in the Docker Hub repository and give it that image to anyone, he will replicate the same environment setup in your machine. So suppose I have done this all setup and I create an image of this and I will give this image to everyone, or I will store this image in my Docker Hub repository, public image. Anyone can pull the image, just use the pull command and say pull image, and my image will come and everything will set up automatically. So nobody has to do this manual configuration of Hive, Scoop, everything, no need to do. So that is the main advantage of the containerization. Basically, you are not doing everything from the scratch. You are already built in once, and then you are distributing into the multiple team members, and they can do it. Okay. So that's the main advantage of using the Docker, Kubernetes containers, pipelines. So these all things providing the automations. DevOps environment is just helping to the big data to make it more infrastructure automation and configuration. So this is helping in the building infrastructure setup things. But finally, application development need to be done by the developer only, right? So like we will be saving our time in the infrastructure setup. Today we have spent 3 hours for installation of these things. If I show this installation by Docker Kubernetes in 5 minutes, then we will be saving our lot of development time, right? So that's the main like advantage of using the DevOps in any technology, not only for big data like Java, Python, okay, data science, any technologies are using the DevOps, because without DevOps, they cannot make it automation infrastructure setup. Okay. Okay. Anyone has any question? So this is more explore, right? Like as much as you explore, right? Not only make it yourself stick to only I have to learn big data. I don't need to learn the DevOps because this is not my cup of tea. But now the scenario is completely changed in the market. if you are showing more skills, even you don't know the extensive knowledge in that particular area, but at least you are aware, or you are making them understand, okay, you able to work, right, if you get a chance. Or at least you can do monitoring part and support bug fixing part, you can do in the infrastructure setup environment part, you can do. So that is also enough. Nobody is asking you to expertise in the Docker Kubernetes, because already the DevOps team is there in the project and they will be handling all those sort of things. Okay, so you are not worrying about that, but at least they ask you to understand like how to monitor, how to schedule job, how to set up. So pipeline things you are not writing. You are not writing the CI/CDs, right? You are not writing any CI/CDs. You are just going to monitor. So if you are understanding these terms and you are able to understand the environment, then it will be easy to debug for you. So as a developer, you can do fixing quickly, right? If you understand the logs, right? How to check the logs in the containers, right? If you don't know the logs of the container, so you have to depend on the DevOps guy and you have to ask the DevOps guy. So why it is necessary, like our knowledge should be up to date for all this configuration environment things, okay? Is it making sense, right, everyone? Right? Any? So
Yes, yes,
we
it's
cover
making
the
sense.
Git Jenkins, okay, and more will be the theoretical part, okay, because I'm not going very extensive the Docker Kubernetes, but I will make you understand like how can we make it our application Dockerize, containerize, how can we store image, how to pull image, how to delete image. So I think that knowledge is sufficient. Like you can do any if you get any compose YML file or you are getting Docker files, so you can create your own containers, you can create. Okay. Okay, fine. I will share the recording. Both the recordings I'll upload in the drive and share to, yeah, and you guys can follow.